Okay, now I'm going to do 23 and 24. 23 I really had to think about, and I told one person, I think it was Hogan Daughters, to do it wrong, so I had to go back and correct that. So what I know is I have a battery that has some internal resistance, and they want to know what is that internal resistance. Well, the current is 117 milliamps, or 0.117 amps. And I know the resistance of the load, which is just the devices that the circuit is going to operate, is 78 ohms. And I know that the voltage was 9 volts. That was the terminal voltage. That's the voltage that it came to me from the manufacturer. So I said, well, the terminal voltage is equal to the EMF minus the IR. The EMF is the voltage on the load. So I said 9 volts is equal to, well, the load is 78 ohms, and it's going to draw 0.117 amps minus 0.117 amps times some internal resistance. Well, this is 9.126 volts. So 9 volts minus 9.126 volts is equal to 0.117 amps times little r. So 0.126 divided by 0.117 will give me the little r, and so the internal resistance was simply 1.07. 1.08 actually would be better, more accurate, 1.08 ohms. Now, 24 was some capacitors. And so if I looked at 24, I had C1, C2, and then I had a group of 3 capacitors that were parallel to each other. And the way that I know they're parallel is that there are 3 separate pathways for the charged Apollo. So that always tells me things are parallel. If there's more than one path, I know it's parallel. So I said, oh my goodness, what am I going to do? Well, here's C3, C4, C5. In our notes, I told you that C total for the parallel is C3 plus C4 plus C5. So I had 1 microfarad, 2.5 microfarads, and another microfarad. Oops. So that whole group was worth 4.5 microfarads. Well, that's great. So I'm going to redraw it. Here's C1, C2, and then that combination. And they're all still hooked up to the same battery. So C1, sorry, that looks like a capacitor instead of a battery. So C1 had a value of 1 microfarad. C2 was 2 microfarads. And then this group was replaced by a 4.5 microfarad. Now they're in series, so I have to do 1 over CT, because we're talking about capacitors, is 1 over 1 plus 1 over 2 plus 1 over 4.5. And so rather than mess with finding a common denominator, I use the x to the minus 1 key. And when I use the x to the minus 1 key, I got my total capacitance to be 0.58 microfarads. All right, that's great. Now, I got to go back and find out some stuff about this one right here, I think it is. Let me see. Yep, that one right there. So, they want to know what the charge on that one is. Well, what I know is the charge here, here, and here is the same. So I'm going to say Q1 equals Q2 equals Q on the group. And that's equal to Q total. Well, Q total is C total, V total. C total is 0.58. V total was 18 volts. So when I multiplied that, I got 10.45 microcoulombs. Okay, so there's 10.45 microcoulombs here, 10.45 microcoulombs there, and then this group is going to get 10.45 microcoulombs. Well, what I know about this group is that everybody here has the same voltage, so V3 equals V4 equals V5. So I'm going to say, well, V is equal to Q over C. So the charge for that group was 10.45. The capacitance of that group was 4.5. How do I know? I did it right up here. So the micros will cancel out, and so the voltage, 3, 4, and 5, I got 2.32 volts. Let's get this out of the way. 2.32 volts. Now, that's still not what they wanted to know. They wanted to know what is Q4. Well, Q4 is C4V4. C4 was 2.5. Yeah, C4 was 2.5 microfarads. V4 was 2.32 volts. So if I multiplied that times that, Q4 wound up being 5.81 microcoulombs. And I'm done. Hope that helped.